Okay, so today we're going to learn about distance and displacement. This is going to start our segment on motion and forces, okay? So, when you were small, you understood distance in a general way. Distances were limited to your house and your yard. As you got older, your activities covered greater areas, and your range increased to include school, homes of friends, and the streets joining those places. You eventually learned to use tools such as rulers and measuring tapes to measure certain distances. Nowadays, if you drive, you are developing an even more refined sense of distance, especially if you have to pay for the gas. You are now at the stage to learn more about how scientists deal with distance and measurements related to it. This lesson starts the discussion. You will review systems of measurement and learn how the concept of displacement and learn the concept of displacement. You will then use these concepts to work problems related to distance. Some vocabulary that is important to know. Displacement. Displacement is the straight line distance between 2 points, a measurement of the net change in position. Distance is the length along a path between 2 points. And a vector, a measurement that has both magnitude, which is a numerical value, and direction. Okay, so a quick review of the metric system. The metric system is based on the decimal system, or multiples of 10. Scientists all over the world use it. The fundamental unit of distance is the metric system, is the meter. A meter can be divided into 100 units called centimeters, or into 1,000 units called millimeters. For long distances, the convenient unit is the kilometer, or 1,000 meters. For comparison, a meter is a little longer than a yard. 1 inch is about 2.5 centimeters, and a kilometer is a little longer than half a mile. The following chart reviews the prefixes used in the metric system. So in the middle here is your base unit, a gram, a liter, or a meter. When you have a decimeter, or a deciliter, or a decigram, then you have a unit that is smaller than 1, okay? So as a fraction, this is represented as 1 over 10. But as a decimal, it's a 0.1. It's in the 10th place. A centimeter is 1/100th, which is expressed as a 0.01. A millimeter is a 1,000th, which is a 0.001, and then so forth. On the other side, you've got a decameter. You could have a decaliter, or you could have a decagram. It's bigger than this 1 unit. It's 10 times bigger. See, 10 times bigger than that 1. So if you have a decameter, that's 10 meters, or 10 liters, or 10 grams, depending on what you're measuring. Hecto is 100. Kilo is 1,000. Converting from one unit to another in the metric system is very simple. The decimal point is merely moved to the right when multiplying by 10,000. When multiplying by 10, 100, or 1,000. For example, 1.5 meters equals 150 centimeters. So if we had 1.5 meters and we wanted to get all the way over here to centimeters, we'd have to move our decimal places 2 points. Move it once, move it twice. So that's what we did here. We took that decimal point, we moved it once, we moved it twice, and that's how we got 150 centimeters. The decimal moved 2 places to the right. When dividing by multiples of 10, just move the decimal point to the left. So 320 meters equals 0.32 meters. The decimal just moved 3 places to the left. Defining distance and displacement. In everyday language, when one wants to express how far, the term distance is commonly used. However, this term has a very specific meaning in science. It is defined as the length along a given path between 2 points. But distance does not necessarily indicate how far apart the 2 points are. To express the straight line length between the 2 points, the term displacement is used instead. It is important to distinguish between the two terms. For example, let's say you went on a road trip from New York to Los Angeles. At the end of the trip, your car odometer would read approximately 4,467 kilometers. This is the distance you traveled along the roads between two cities. If you were to take a plane, however, the trip would be about 500 kilometers less. This is because the displacement, or straight line length, between these two cities is only 3,961 kilometers. But you must consider one other factor when using the term displacement. Displacement is also a vector, which means it has both magnitude, a numerical value, and direction. Since Los Angeles is southwest of New York, the actual displacement for this trip would be 3,961 kilometers southwest. The difference between distance and displacement is illustrated on the following map. Okay, so distance is the blue and displacement is the red. They're both from one point to the other, but they're not exactly the same. Okay, take a look at the following examples to practice what you have learned about distance and displacement. Distinguish between the distance and displacement from point A to point B. Refer to the following diagram. If you measure along the zigzag path from A to B, you are measuring distance. To determine displacement, you must measure a straight line between A and B. Okay? So see that dotted line? That's the displacement. If you measured this line, all of this stuff, this line all the way around, if you took all those measurements, you would be measuring the distance. But the displacement is the actual straight line space between A and B. So let's think of an example. Susan rides her bike 36 meters to the store. The store is northeast of her house, and there is a straight line path on which she can ride her bike. After going to the store, she rides to her friend's house. Her friend lives 25 meters farther along the same straight path to the northeast. What distance has Susan traveled? Well, it tells you that first she takes her bike to the store, and then she goes to her friend's house. So the distance is easy. That's the easy part. 36 plus 25 equals 61 meters. You just have to add the two values together. But the displacement is different. Displacements along a straight line can be added algebraically. In this case, the magnitude of the displacement is the same as the distance. However, remember that displacement also has a direction. Susan's displacement is 61 meters northeast. So it's different because it adds the direction. Here's another example. Jim takes his dog on a walk. He walks straight for 512 meters. He then turns around and walks back east along the same path for 302 meters. What distance has Jim walked? So he went 512, then he walked 302. We don't care about the directions because we're talking about distance. So the distance was 512 plus 302 equals 814 meters. But what is his displacement? Remember that displacements along a straight line can simply be added. However, direction must also be considered. The two parts of this trip have opposing directions. Therefore, to determine displacement, let's call west the positive direction and east the negative direction. So first, Jim walked 512 meters west. And then he backtracked. He went 302 meters east. So he basically walked 512 meters west. He turned around and walked back 302 meters the opposite direction, which is east. So that's why you take 512, you subtract 302, and you get 210 meters west. Because when he stopped walking, he was facing towards the west. First he went 512 west, he came back and went 312 east, and that leaves 210 meters west still left. Here's another example. Excuse me. Consider a 100-meter race taking place on an oval track. The race consists of one lap around the track. In other words, the runners start and finish at the same point. What is the displacement of the runners after one lap? Because the runners start and end at the same point, their displacement is 0, but not their distance. Their distance is 100 meters. So in review, there are many different methods for measuring distance and displacement. In this lesson, you have reviewed the metric system, which is accepted by scientists the world around. You have also been introduced to the idea that common terms also often have very specific meanings in science. And in everyday sense, the terms distance and displacement are interchangeable. However, in science, they have unique meanings. Distance is how far something has traveled on a path between 2 points. Displacement is the straight line length between the 2 points. Displacement is also a vector, so it has direction as well as magnitude. Okay, now you're going to go to your assignment and finish the questions.